Integrated circuit, fuse and switch. Integrated circuit, IC. Our world is full of integrated circuits. You find several of them in computers. For example, most people have probably heard about the microprocessor. An IC is an electric circuit made from different electrical components such as transistors, resistors, capacitors, and diodes that are connected to each other in different ways, along with their interconnecting electrical conductors, processed on the contained entirely within a single chip of silicon. Jack Kilby at Texas Instruments saw the opportunity to find a solution to the miniaturization project of integrated circuit who wired bonded three transistors together into what today would be called a system in a package, SiP. It wasn't until Robert Noyce merged the planar process with the idea that the modern integrated circuit was invented. Robert Noyce also was one of the co-founders of Intel, one of the largest manufacturers of integrated circuits in the world today. Advantages of IC technology. 1. Compactness, it is designed to economize space. 2. High speed, interconnections among the components within an IC are physically tiny, making high switching speed possible. 3. Low power consumption, they use less power than equivalent discrete component circuits. It produces less heat, which therefore translates into better efficiency. 4. Reliability, IC circuit fails less often, per component hour of use than systems that use discrete components. 5. Ease of maintenance, repair procedures are simplified when failures occur. Many appliances use sockets for ICs, and replacement is simply a matter of finding the faulty IC, unplugging it and plugging a new one. 6. Modular construction, in this scheme, individual ICs perform defined functions within a circuit board. The circuit board or card, in turn fits into a socket and has specific purpose. Classification of ICs. Despite the amazing advantages of ICs, and capabilities that continue to broaden each year and displace more and more discrete electronic components, ICs still have limitations: comparatively low power, low voltage, and a limited selection of components that can be integrated economically. Below is the classification of different types of ICs bases on their chip size. 1. SSI, small scale integration. 330 gates per chip. 2. MSI, medium scale integration. 3300 gates per chip. 3. LSI, large scale integration. 300 to 3000 gates per chip. 4. VLSI, very large scale integration. More than 3000 gates per chip. Types of integrated circuit, IC. 1. Linear IC. It is used to process analog signals such as voices, music and radio transmission. Examples: operational amplifier or op-amp differentiator, op-amp integrator, voltage regulator IC, timer IC, multiplexer IC, comparator IC. IC78XX, it is a family of self-contained fixed linear voltage regulator integrated circuits. The 78XX family is commonly used in electronic circuits requiring a regulated power supply due to their ease of use and low cost. For ICs within the 78XX family, the 20th is replaced with 2 digits, indicating the output voltage. For example, the 7805 has a 5-volt output, while the 7812 produces 12 volts. The 78XX lines are positive voltage regulators, that produce a voltage that is positive relative to a common ground. 2. Digital IC, digital logic IC. It operates using 2 discrete states, high, logic 1, and low, logic 00. It contains massive arrays of logic gates that perform Boolean operations at high speed. Examples: transistor logic or TTL, emitter coupled logic or ECL, and metal oxide semiconductor logic. 3. Memory IC-binary digital data, in the form of high and low levels, logic 1s and 0s, can be stored in memory X. The data can be easily changed and stored back in RAM. It takes various physical forms such as a random access memory, RAM, chip, which is sometimes called read-write memory. It is categorized into dynamic RAM, SRAM, and static RAM, SRAM. B read-only memory, ROM, chip, which can be easily accessed, in whole or in part, but not easily written over. Example, erasable programmable ROM, EPROM, chip, which is an IC whose memory is of the read-only type, but that can be reprogrammed by a certain procedure. IC pinouts. The pins on an IC chip provide connections to the tiny integrated circuits inside of your electronics. To determine which pin is which, you look down on the top of the IC for the clocking mark, which is usually a small notch in the packaging but might instead be a little dimple or a white or colored stripe. By convention, the pins on an IC are numbered counterclockwise, starting with the upper left pin closest to the clocking mark. So, for example, with the clocking notch orienting the chip at the 12 o'clock position, the pins of a 14-pin IC are numbered 1 through 7 down the left side and 8 through 14 up the right side. Fusible link, FUSC. Fuse is to combine two objects via the process of fusion. In electrical engineering, a fuse or fuse, short for fusible link, is a type of overcurrent protection device that has primary uses. A. It melts or breaks when the current exceeds a predetermined amperage value. B. It will open the circuit of which it is part. C. It will protect the circuit from an overcurrent condition. A fuse is usually rated in amperes, which represents the maximum continuous current it could handle without blowing. The most popular type with a G indicates a glass material and A indicates that intended for automotive applications. A 3-AG fuse measures approximately 32 mm by 6 mm. The fuse has no recorded history. It only appeared after several inventions in electronics. Testing of fuse. In testing a fuse, there are some physical signs to look for in a fuse which will indicate if it needs to be replaced. Some signs are busted filament, burnt color of fuse, and broken fuse. Here are the steps in testing using multitester. 1. Set your multitester to ohm meter range X1. Don't forget to calibrate your multitester after selecting ohm meter range X1. 2. Connect the test probes in any direction because fuse doesn't have polarity. The tester pointer should deflect and has a low resistance reading. Good condition. Fuse is in good condition if the tester pointer deflects and it has a low resistance reading but not rest in 0 ohm. Defective fuse. The tester pointer doesn't deflect at all, the fuse is open. Switch. Switch is nothing but a device which is used to turn on and off the equipment. It is an electrical switch controls the mechanical or electrical or electronic device for making or breaking or changing the connections in a circuit. It is also the gate for the entrance of current to a specific device. Switches have the following functions. A. Allows us to control the circuit operation. B. Permits man to safely control a light or any one of the million other electronic devices. C. Turning off the switch will open the circuit, which means there is no current cycle. D. Turning on the switch will close the circuit, which means there is a current cycle. The switch has no recorded history as well. Together with the fuses, it is the product of the unending discoveries of electronics that makes life easier and makes automatic lifestyle possible. Mechanical switches require physical or manual contact with switch for operation. It further classify into different types of switches based on number of poles and throw. Poles means the number of input circuit, power circuit, available to the switch. Throws means the number of output circuit, number of path in which current can flow, available to the switch. 1. Single pole single throw, SPST, most common. 2. Single pole double throw, SPDT. 3. Double pole single throw, DPST. 4. Double pole double throw, DPDT. 5. 2 poles 6 throw, 2P6T. 6. Momentary operation switch, momentary control switch. A. Push button. B. Pressure switch. C. Temperature switch. D. Toggle switch. E. Rotary switch. Testing switch using the ohm meter. Here are the steps in testing using multitester. 1. Set your multitester to ohm meter range X1. Don't forget to calibrate your multitester after selecting ohm meter range X1. 2. Connect the test probes in any direction because switch doesn't have polarity. Good condition. Switch is in good condition if the tester pointer is on position, the pointer deflects with low resistance reading off position, the pointer does not deflect or in infinite, reading. Defective switch. The defects or troubles that may occur in the SPST switches are shorted contact element and open contact elements of the switches. Thank you for watching.